All right, my dear viewers, in this slide, we want to quickly look at factors affecting the velocity of sound in air. Then we are going to use that factor to solve this question. So quickly, what are the factors that affect the velocity of sound in air? In my previous slide, I showed you the velocity of sound waves in different media. I said in solid, the velocity of sound wave is about 5,000 meter per second. I said in liquid, that is water, the speed of sound is about 1,500 meter per second. And in what? Air, the speed of sound is about 330 meter per second. Having said that, now there are some factors that affect the velocity of sound. These factors, when they affect the velocity of sound, they either increase the velocity of sound or they reduce the velocity of sound. What are these factors? Number one, let's call it what? Temperature. Call it what? Temperature. Temperature. So, how does temperature affect the velocity of sound? It's very simple. Increase in the thermodynamic temperature will lead to increase in the velocity of sound, and decrease in temperature will lead to decrease in the velocity of sound in air. Mathematically, if this is the velocity of sound in air, we're made to know that the velocity of sound in air is directly proportional to the square root of the thermodynamic temperature. That is the absolute temperature. So moving further, we have V is equals to K the root of T. Now finding K is equal to V divided by the square root of T. Then we can express this in this form. We have a V1 divided by T, square root of T1 is equals to V2 divided by what? Square root of what? T2. Of course, your T1, take note in examination, where V1 is the what? Initial velocity. Is the what? Initial velocity of sound. And T1 is the absolute temperature. Is it what? Absolute temperature at 0 degree. At what? 0 degree. That's at 0 degree Celsius, which you are going to convert to Kelvin, which is going to give us 0 degree Celsius plus 273 in what? In Kelvin. In Kelvin. And V2 is the final velocity of, that is the final speed of sound, final velocity, and T2, of course, T2 is also what? That is the second temperature. That's the what? Second temperature. Take note of this. We are going to make use of this to solve this question. Another factor that affects the speed of sound is wind. Now, if the wind is blowing in the direction of the sound, it is going to increase the speed of sound. And if the wind is blowing in the opposite direction, it is going to decrease the speed of sound. For example, if I am calling somebody in my front and there is wind is blowing, and wind is blowing in the direction where I am shouting the name of my friend, it means that the direction, because the direction of the wind is in the same direction of the sound I am making, it is going to increase the velocity of my sound. But if the wind is blowing in this direction and I am making sound in this direction, it is going to reduce the velocity of sound. That's how wind affects velocity of sound in air. And finally, we also have pressure. How does pressure affect the velocity of sound? No. Pressure has no effect. Pressure what? Has no effect on that. And we also have another factor, which is what? Humidity. Use what? Humidity. So humidity increases as velocity increases. Do you understand? So I've